If you've ever heard someone say, coolant is coolant, just drain it and pour new stuff in, that's the kind of advice that can turn a perfectly healthy Toyota into an overheating headache. Because the cooling system doesn't just hold liquid. It holds pressure, it traps air, it opens and closes passages with the thermostat, and it relies on the right chemistry to protect aluminum, seals, and the water pump. Miss one small step and you can end up with a temperature gauge that looks normal at idle, then spikes the moment you drive up a hill or sit in traffic with the AC on. So if you're here for coolant replacement in Toyota Corolla Cross, the real goal isn't simply new coolant. The goal is a system that's full, bled of air, using the correct coolant type, and verified after a heat cycle so you don't get surprised 2 days later. Let's start with the part most people rush, deciding what replacement even means. There are two common approaches. One is a drain and fill, where you drain what you can from the radiator side, then refill with the correct coolant. The other is a more thorough flush, where you rinse with distilled water until what comes out is clean, then refill. A drain and fill is often enough if the coolant isn't contaminated and you're simply doing routine maintenance. A flush makes sense if the coolant is rusty, oily, full of debris, or you have no idea what was used before and you suspect the wrong chemistry was mixed in. The catch is that a flush done carelessly can introduce more air and more opportunities for leaks, so more aggressive isn't automatically better. Now the chemistry. Toyota typically uses a long-life, pink coolant for many modern models, often sold as Toyota Super Long-Life Coolant. The key idea is not the color by itself, but the specification and compatibility. Different coolants can use different inhibitor packages, and mixing them can reduce protection or create sludge-like deposits. If you're not 100% sure what's in the car, the safest move is to check the owner's manual and the label on the reservoir cap area, then buy the correct Toyota spec coolant or an equivalent that explicitly states compatibility with Toyota SLLC type coolant. If you're choosing between concentrate and premix, premix removes one big variable, water quality. If you do use concentrate, only mix it with distilled water. Tap water can carry minerals that slowly build deposits inside the radiator and passages, and that's the kind of problem you don't notice until the system is partially clogged. Before touching anything, safety. Coolant is toxic, it tastes sweet to animals, and even small spills can be dangerous for pets. Also, a hot cooling system is pressurized. Opening it hot can spray boiling coolant. So the engine must be fully cold. Not warm, not, I can touch the hood, but cold enough that the upper radiator hose feels cool and there's no pressure when you gently squeeze it. What do you need? A drain pan big enough to catch what comes out, gloves, rags, and ideally a funnel that fits securely. If you can, have a spill-proof funnel or a funnel with an extension. You'll also want distilled water if you plan to rinse. And you need a plan for disposal. Most auto parts stores or local recycling centers accept used coolant, but don't pour it down a drain and don't leave it sitting around. Now, where are you actually working on a Corolla Cross? You'll have a coolant reservoir, usually a translucent plastic tank with MIN and max marks. That reservoir is not the whole system. It's an expansion tank that catches overflow and feeds coolant back as the system cools. The main fill point may be a radiator cap or a pressurized cap on a separate fill neck, depending on the exact configuration. Some modern layouts make the radiator cap hard to access, and some rely more on the reservoir for filling. This is where people get into trouble. They top off the reservoir, see it at max, and assume the engine is full. Meanwhile, the engine side can still be low, with an air pocket sitting near the thermostat housing. You'll also have a drain point. Many vehicles have a small drain cock on the radiator, usually low on one side. Some also have an engine block drain, but it may be difficult to access and is not always practical for a DIY job. If you can only do the radiator drain, that's still a valid drain and fill, just understand you're not removing every drop. That's normal. Here's the mindset that prevents mistakes: you're not just swapping liquid, you're managing air. Air is compressible, coolant isn't. Air pockets can stop circulation, create hot spots, and delay thermostat operation. That's why a simple job can lead to overheating. Alright. Engine cold, car park level, heater controls ready. Before you drain anything, take a quick look at the reservoir level and the color of the coolant. If it looks milky, oily, or full of rust particles, that's a sign to stop treating this as routine maintenance. Also look around hoses and clamps for crusty residue, which can indicate slow leaks. Coolant replacement won't fix a leak, it will just make it more obvious. Now drain. Place your drain pan under the radiator drain area. Open the reservoir cap first, slowly, just to make sure there's no pressure. Then open the drain cock or remove the lower drain plug if that's what your setup uses. Coolant should flow steadily. If it dribbles, you may need to open the cap more to let air in so it drains faster. Let it drain until it slows to a drip. At this point, you have a choice. If you're doing a simple drain and fill and the old coolant looked clean and correct, you can close the drain and move on to refill. If you're doing a rinse, you close the drain, add distilled water, run the engine long enough to circulate, then drain again. The important nuance is, long enough to circulate means long enough for the thermostat to open. If the thermostat never opens, you're mostly rinsing the radiator and reservoir, not the engine passages. But you also don't want to run it too long with mostly water if you're in a hot climate or you're idling for ages. This is why many people keep it simple unless there's a reason to flush. Assuming you're ready to refill, close the drain securely. Don't over-tighten plastic drain cocks, they can crack. Wipe the area so you can later tell if it's leaking. Now we get to the step that decides whether this job is boring or becomes a problem, filling and bleeding. If your Corolla Cross has an accessible radiator cap or a dedicated fill neck, that's typically the best place to fill because it's the high point of the system. Fill slowly. Slow matters because it gives air time to escape instead of getting trapped. You'll often see the level rise, then suddenly drop as coolant finds its way into passages. Keep topping up. If you have a spill-proof funnel, this is where it shines. It creates a little reservoir above the fill point so bubbles can burp out without making a mess. If you don't have a radiator cap access and the system is designed to be filled through the reservoir, you can still do it, but you have to be more patient with the warm-up and recheck. Fill the reservoir to the correct mark, but understand that the system may pull coolant from the reservoir as air purges and as the thermostat opens. That's normal. What's not normal is letting it run low and suck air again. Now set the cabin heater to hot. People argue about whether this matters on every modern car, but the safe habit is to set it to hot so coolant can circulate through the heater core if the valve is open. You're not doing this for comfort. You're doing it to avoid leaving a pocket of air trapped in that part of the system. Put the fan on a low setting so you can feel when it starts blowing warm air. Start the engine and let it idle. Watch the coolant level at the fill point or in the funnel. At first, you may see small bubbles. That's good. That's air leaving. As the engine warms, the level may rise slightly, then drop. Keep it topped up so it never gulps air. This is the part people rush because it feels like nothing is happening. But inside the engine, the thermostat is still closed, and coolant is mostly circulating in a smaller loop. You're waiting for the thermostat to open, and when it does, the level often drops noticeably because coolant suddenly fills the radiator and larger passages. How do you know the thermostat opened if you don't have scan tools? You can feel the upper radiator hose. It will go from cool to suddenly hot as coolant begins flowing through the radiator. Another clue is the heater output. It should become consistently warm, not just a brief warm puff. And eventually, the radiator fan may cycle on and off. Fan cycling is a good sign that the system is reaching operating temperature and the radiator is doing its job. While it's warming up, keep an eye out for warning signs. If the temperature gauge climbs higher than normal, shut it down and let it cool. That can mean a big air pocket. If you see violent bubbling that doesn't settle, that's not the same as normal burping. Don't jump to scary conclusions, but don't ignore it either. Normal burping is intermittent bubbles that reduce over time. Abnormal is constant frothing or pushing coolant out aggressively. Once the thermostat is open and you've seen the level stabilize, let it run a bit longer so remaining air can work its way out. Then turn the engine off. Let it cool down fully. This cooldown matters because as the system cools, it contracts and pulls coolant from the reservoir. If you only check it hot, you can fool yourself into thinking it's full when it's not. When it's cold again, check the reservoir level. Adjust it to the correct cold mark, usually between min and max depending on the markings. Don't overfill. Overfilling often leads to the system purging excess coolant out of the overflow as it heats up, and then people think they have a leak. The system needs expansion space. Now, a quick word about how much coolant, because that's another trap. People want a single number. But the amount you drain is not always the full capacity, especially if you didn't open a block drain. So instead of chasing a number, chase the correct level and the correct behavior. If you drained, refilled, bled, and the reservoir level stabilizes after a heat cycle, you're in the right zone. If you're using concentrate, the ratio matters, but without knowing exactly how much water remains in the system after a partial drain, it's easy to end up with a mixture that's too diluted. That's one reason premix is popular for drain and fill jobs. You're less likely to end up with a weak mixture. If you do use concentrate, you need to think through what's left in the system and aim for an appropriate final mix, and if you're unsure, it's better to avoid guessing and use premix or follow the manual's guidance. Let's talk about the mistakes that caused that "it was fine in the driveway, then it overheated on the road" story. The first is filling only the reservoir and never getting coolant into the engine side properly. The reservoir is not a magic portal. It's part of the system, but it doesn't guarantee the block is full if air is trapped. The second is mixing coolants because the colors look similar. Color is not a specification. 2 pink coolants can still be different. 2 green coolants can be different. If you're topping off in an emergency, you do what you must to protect the engine, but for maintenance, stick to the correct spec. The third is using tap water. It seems harmless. It's not instantly catastrophic. It's just a slow, boring way to shorten the life of the cooling system. The fourth is rushing the bleed. People get impatient, cap it early, and drive away. Then the air pocket moves, the thermostat sees steam instead of liquid, and the temperature spikes. Or the heater blows cold at idle because the heater core is full of air. That's not a heater problem. That's a bleeding problem. The fifth is ignoring the recheck. The system can look perfect right after you finish, then after the first real drive and full cool down, the reservoir level drops because the last bit of air finally worked out. That's why the recheck is part of the job, not an optional extra. Now, what if you did everything and the reservoir keeps dropping day after day? A small drop after the first heat cycle can be normal. Repeated drops are not. That can indicate a leak, or that air is still purging because the system wasn't fully bled, or in rarer cases, another issue that needs diagnosis. The smart move is to inspect for wet spots around hose connections, the radiator area, and under the car after parking. Also check for a sweet smell. If you can't find anything and the level keeps falling, that's when you stop guessing and consider a proper inspection. Also, be aware of packaging differences. Some Corolla Cross variants, including hybrid configurations, can have slightly different layouts and additional cooling circuits. That doesn't change the fundamentals, but it does mean you should verify the exact fill points and the recommended coolant in your owner's manual. If you're ever unsure where the main fill point is, don't force it. The wrong cap on the wrong tank is a real mistake people make. Now let's put the whole procedure into one clean mental run, because this is where coolant replacement in Toyota Corolla Cross becomes straightforward instead of stressful. Cold engine. Open cap carefully. Drain into a pan. Close drain. Refill slowly with the correct Toyota spec coolant. Heater set to hot. Idle and watch the level. Wait for thermostat to open and for heat to come through the cabin. Top off as needed. Let it cool completely. Set the reservoir to the correct cold level. Then drive it, let it cool again, and recheck. Verification is where you earn confidence. On the first drive, you're not trying to set a lap time. You're watching behavior. The temperature gauge should rise to its normal spot and stay there. The heater should blow consistently warm when requested. You should hear or notice the radiator fan cycling at some point, especially if you sit for a minute after driving. When you park, look underneath for drips. When it cools, check the reservoir level again. If it's slightly lower, top it to the correct mark and monitor. If it's dramatically lower, don't keep driving and hoping it fixes itself. One more nuance, don't judge the level right after shutdown. Hot coolant expands and the reservoir can look high. The only meaningful set point is when the engine is cold. That's when the MIN and max marks actually mean something. And please treat the old coolant like hazardous waste. Seal it in a container, wipe spills, rinse the area with plenty of water if you spilled on the ground, and take it to a proper disposal location. It's one of those unglamorous steps that matters. If you do all of this, you'll avoid the 2 classic DIY outcomes, the mystery overheating that comes from trapped air, and the slow damage that comes from the wrong coolant chemistry. Coolant replacement in Toyota Corolla Cross isn't hard because the car is complicated. It's hard because the system is unforgiving when you skip the boring parts, slow filling, proper bleeding, and the next day recheck. Do it patiently, verify it like you don't trust it yet, and you'll end up with the best kind of result. Nothing happens. No overheating, no smells, no puddles, no drama. Just a Corolla Cross that runs at the temperature it was designed to run, mile after mile.